So we've had the, what's happening in Australia and in South Korea, and I'd like to talk a little bit about the situation in the UK and our approach to digital twins. If I can get the slides to move. Thank you. Okay, so the agenda I'd like to talk about is a little bit about digital twins in the UK from a UK government point of view. I'd like to talk about our National Digital Twin Programme, which is, there's a lot of common things that I saw in Sanki's presentation. And then I'd like to talk a little bit about some UK use cases. But before I do talk about the use cases, I think it's quite important to sort of bring out some things about a digital twin definition that is widely adopted in the UK. Okay, so digital twins in the UK, they've been generally supported by government for a number of years. We can certainly trace it back as far as 2018, and there was probably a lot more informal development before then. It is centred around the National Digital Twin Programme, and it is currently funded through an innovation programme called the Connected Places Catapult in the UK. And the UK government, they see lots of advantages in developing digital twins for remote monitoring. And what that does, it enables predictive maintenance for the items that you're modelling, increases efficiency, reduces costs and mitigates risks. So they are sort of key advantages that governments see. The UK government also are starting to use digital twins in a wide range of sectors, particularly where there's high-value assets or complex things to model. And I've got a really good example of that later on. And then moving on to the future, the other key advantage that is seen is interconnected systems. So federating digital twins together to leverage even more advantages. Recent developments in digital twins are exactly that. We're starting to look at federated systems and how they work. And we're pushing on sort of enabling technologies which will allow digital twins to perform even better. And when I say enabling technologies, I'm talking about artificial intelligence. I'm talking about the development of 5G networks and virtual reality. Pushing those technologies will mean that our digital twins in the UK will push forward. However, there are challenges and risks developing digital twins in the UK, and they are being brought out by the 4 points on the slide there. So data issues that this group are probably looked at, of data protection, ownership, are coming to the fore. So these really need to be thought out, pinned down, and monitored going in the future. Also, we're looking to bring down the cost of putting digital twins together. And what we see in the UK is by developing these enabling technologies further, then the cost of putting digital twins together will come down. And the also thing that, which is good news for ourselves really, is that a lack of standardized framework for the development network of digital twins is seen as a challenge. So for the likes of this group, and it's really good to hear Songki addressing that very issue here in Korea. So these are things that we obviously need to work on. And then finally, the sort of data sharing and security. There are concerns from the public about how all this data gets used. So we need to maintain our work in that area. Okay, so a little bit about the National Digital Twin Programme. As I say, it can be traced back to about 2018. maybe a bit earlier than that. And the bullet points on the left-hand side there are all parts of what the National Digital Twin has been working on. The first thing I'd like to point out is the Gemini principles. Now, these have been around for a little while, and they actually have stood the test of time. So if you actually have a look at them now, nobody would really disagree that a digital twin has to have purpose, that it needs to be trustworthy. We need to be able to trust the data and the authoritative data that's in there, and that it also needs to have function. I think that sometimes we create these fantastic 3D data sets, and they don't really have a lot of function beyond being a pretty picture. So it's good to look back sometimes and look at where all this work has come from. But those principles, I say, were developed a number of years ago, and I still think they generally hold true. Another key aspect of the National Digital Twin Programme is a digital twin hub, is what we call it, which is really the outreach. It's a vibrant industry-led community that engages with a growing number of sectors throughout society, pushing the idea of digital twins, getting people involved. We've found that really useful in the UK to draw out new use cases and develop twins. But also it's quite influential. Another piece of influential work is the information management framework that's been put together, which is really the guts of it. You know, it's a collection of open, technical, non-technical standards to make sure that digital twins happen. And part of that is addressing the interoperability of data through the development of those standards and the information management network. Digital maturity is also important to the programme, and what that is really gaining an understanding of where the industry is now and where it needs to go in the future in relation to both digital transformation and the digital twins being a key objective of the programme. And then the bottom three there, you could probably guess that they would be part of the work. So developing the legal agreements, yes, that's something that we need to do. Data sharing has come up as a major issue with parts of digital twins, because you're capturing data from lots of disparate sources. Actually getting around the table and putting a legal data sharing agreement together can be quite difficult. Developing data visualization tools is also seen as something, I think we're probably about there now, but in the initial days it was difficult to see what people were talking about. And obviously engage with government, industry and academia. Okay, so before I talk about a couple of use cases, I'd like to have spend a little time on a digital twins definition. So in the UK, this definition here that comes from the Digital Twin Consortium really is probably quite widely adopted as a definition. So point number one, a digital twin is a virtual representation of real-world entities and processes synchronized at specified frequency and fidelity. Now, the important word here for me is synchronized. It's not a static picture. It's not a photograph. So it does need to contain both static and dynamic data. And that is where we see the development of 5G networks to support the movement of that data, IoT, etc. All backed up by good standards, obviously. The second part of the definition is that digital twin systems transform business by holistic understanding, optimal decision-making, and effective action. And this really answers the question of what do we want to achieve with the digital twin. We want to improve our understanding of what we're trying to model. We want to make good decisions, and importantly, take action on those decisions, be it traffic congestion, air pollution or whatever. So that's another important component of a digital twin. The third one, digital twins use real-time historical data to represent the past, the present, and stimulate predicted futures. And this is the key one for me, because this is the capability that should answer the what-if questions. So we've put this digital twin together. It's answering the day-to-day stuff, but what we'd like it to do is answer future questions. So, for example, if we allow a housing development to be built in location X, does that have a knock-on effect for flooding in location Y? Those types of scenarios. So you can see that that would be important for climate resilience, for example. And then finally, digital twins are motivated by outcomes, tailored to use cases, powered by integration, built on data, guided by domain knowledge. And this point answers the question of why we're doing it. Yeah, why are we actually spending this time and effort integrating all these data sets? So you can see that is quite a comprehensive definition, and if you were to put a proposal together in the UK or anywhere really, and you can answer those 4 questions, then I think you're starting to move, and people will start and listen to what you're saying. Okay, a couple of slides on some use cases. This is quite a good one at the moment. This is NUAR, which is a National Underground Asset Register in the UK. It's quite simply an interactive digital map of underground pipes and cables. So in the UK underground, we have water, we have gas pipes, we have broadband pipes, we have electricity pipes. So I can give you a few facts if you like. There's about 4 million kilometres of buried pipes in the UK, so that's quite a lot of pipelines. And about 4 million holes are dug every year, right? And on 60,000 occasions, people strike the pipe. They do damage, and not necessarily to their own assets, right? What complicates the matter is that there's over 650 plus organisations in the UK that own those assets underground and don't necessarily know where they all are. So we built a national digital twin to model all that data. 16 government and private organisations have got together to do that. And the estimated economic benefit is about £350 million a year, which is a lot of money, just in reduced number of asset strikes and delays to public and businesses. So the project's been running since 2018. We've now got a minimum viable product, which is now online, and that covers England, Northern Ireland, and the City of London, and we're expecting full coverage in 24, 25. I think it also covers Wales, actually. It's not on the slide. So Scotland has their own system that they've had for a number of years. So a really good example. Now, while they've been working on this, I've known people that worked on this project, and they said that the real difficult bit was what I mentioned earlier on. It was the data sharing agreements. If you try and get 650 asset owners and interested parties together to share data on what are actually confidential information, it is quite a difficult thing to achieve. So these are the things, the challenges that this NUAR project has started to meet. We, like I say, we're now at a stage where there's a minimum viable product that's actually online, and we're hoping to extend that further in the coming years. Okay. So the last minute I've got, just to mention another few use cases in the UK. The first one is it's run by the National Digital Twin Programme, and it's a climate resilience demonstrator. And what they've focused on is the impact of flooding on our utilities, on our energy, our water, and our telecom networks. So essentially, they're able to answer what-if questions. If this area floods, which assets are affected? But more importantly, if the flood takes out a electrical substation, that substation supplies water pumps, it supplies telecommunication networks, etc. you can start and model the damage of if that occurred. And then from that information, then you're able to mitigate and make sure that those assets are protected. Two final ones. The UK Centre for Ecology and Hydrology, which is something slightly different for digital twins. Digital twins, a lot has been in the built environment. This is a digital twin for the soils beneath our feet to improve our understanding of soil moisture, soil carbon, etc. And I think that will be a lot more important in the future as we look at our soils and the degradation of them for the food industry, etc., and for agriculture. And finally, the UK Hydrographic Office in the UK, a worldwide organisation producing navigation data, are using digital twins to take their smart ports idea, autonomous ship navigation, to the next level to navigate the seas. And that's me. Thank you very much for your time.